Hello guys, this is Shiraki again with another video. In this video, I'm going to show you guys how to solve a hypothesis test for proportions. In this case, I'm going to also be using the TI84 calculator to solve it. This problem, so for those who would like to know, I took it from this textbook, Probability and Statistics for Engineers and Science. And this problem 8.45. Now I'm going to try to show you guys the way pretty much most professors want you guys to solve it, okay? Now, before we continue on, please don't forget to like the video, comment below, share it, and subscribe. Now, let's start reading the problem first. Let's see here. A random sample of 150 recent donations at a certain blood bank reveals that 82 were type A. Okay, so just from the first sentence, I can already write down a couple of notes. For a start, I can say N equals, oops, sorry about that. Let's see. N equals 150. And then says there's some sort of an outcome, we should call it X, to be 82. And just remember, this example is going to be for proportions, because they're already giving us, well, actually, the whole chapter is a proportion, but let me show you guys where the clues here, okay? So let's continue on. Does this suggest that the recent percentage of top A donation different from 40%? Here is our clue that will tell us that this is a proportion problem. Okay, so let's go ahead and do P equals, in this case, or P naught. Actually, no, it's not P naught, sorry. This will be just P hat, and this will be 82 over 100, because 82 over 100 people and samples. So using my TI84, and let me go and open it up here. $82 divided by 100 is 0.82. All right. That's a 2, 0.82. Okay. Now I said that this is the actual percentage of top 8 donation different from 40%. So you have to watch your wordings, because most of the time, and when you're doing these problems and intro to stats, the population proportion is at the beginning of the story, but in this case, it's actually at the end. So it's actually telling that the P naught equals 0.4 or 40%. But with this, and then let's see, carry out a test of appropriate hypothesis using significant figure level, of 0.01. And this is a symbol for your significant level. 0.0, oops. Sorry, computer's kind of slow right now. Let me make a nice circle here for you guys. 0.1. And then what you could have the difference if a significant level is 0.05. So we're going to do it to both of them, 0.01 and 0.05. Okay. And they want to know, okay, so your test of the appropriate hypothesis using significant level. Okay, so I'm trying to get the wording right. I don't want to mess it up. So we're doing an alternative hypothesis right now, which is, let me show you guys. All right, so we're doing a hypothesis test. Your HO, or your null hypothesis, is that your P naught is 0.40. And sorry, I have no idea why. All of a sudden, my computer decided to slow down. That means that my HA, I want to, if my P naught is different than not equal to 0.40. Okay? All right. So we're going to be using the calculator because to answer this, we need to compare our p-value with the significant level. Okay? So I'm going to do, let me first clear this. I'm going to do stats, move to the right to test. And I'm going to look for one proportion z-test. You probably have noticed that the sample has both z and t, but the proportion only have the z-test. Okay? All right. And also remember, we're doing proportions because we work with percentages and a decimal format. Press enter right there. My P naught is the, let me make this, make it more. There it goes. Open this up here. Make it away. There we go. That be more dollars. Okay. Zoom out. Can I zoom out? Yeah, zoom out. There we go. Okay. All right. So my P naught is going to be 0.40. Enter. My X, the outcome, is 82. Notice that the P naught in some problem is going to be what the scientists are claiming or what the scientists have concluded in some past study. Okay? And your N is the number of sample, 150, 150. And then here, we're going to select the one that matches the HA. In this case, the not equal. Press enter, down, calculate, and we have these problems here. Now, what all these numbers really means is the following. Let me switch colors here so you can. All right. So it's if we want it's giving us our z, oh my goodness, cannot talk, can't talk right now. That's my place of thought. It's giving us our z score, which is 3.667. Actually, I like to get that extra number. It goes. It's giving our p-value, which I'm going to make this little table here. P-value and significant level. Our p-value is 2.45798 times 10 to the negative 4. Notice the negative 4, the e. Okay? So really in conversion, because a negative 4 really means you're moving the decimal to the left four times, it's really 0.001232457 and 8. And now our significant level, which we were comparing with, is 0.01. And of course, we have the other one, which is 0.05. Now, the question is the p-value smaller than 0.01? If you look at it, I said money, decimals in money, the answer will be yes. So it'll be less than. And at the same time, we can go and answer the the second question, which is also the same thing, less than. Because it's like saying zero point 0.01 is like saying 1 cent, and 0.05 is like saying 5 cents or 5 pennies. And like your p-value, it's pretty much not even in the cents. It's like really small. So right here, we can go ahead and say that your our sorry, I just noticed some numbers are not matching up. Let me go back to the problem here. Let's see, stats, test. Why are we sure I'm doing this right? Number one. Okay, I think I got number. Numbers output. Okay. All right. All right. So here, we can say that because the p-value is smaller than the alpha level on both of them, both are going to have the same conclusion. So when it says will your conclusion be different if a significant level, it's less, it's a 0.5, no, it will be the same. There you go, sorry about that. So the answer are going to be the same, and the conclusion will be the following. Because you want, so that's how pretty much you do it using your calculator. And because your p-value is smaller than your alpha value, we can say the following. Okay, we can say that we can reject the HO. We can also say that. Let me make this bigger. Let me zooming in is good. Zooming in is good. Okay. All right, looks good. Okay. And I'm gonna just change the color. So I can for this reason we can say we reject the HO. Now this only if the p-value is smaller than the alpha. And there is significant evidence to support. You know what happened? Because usually what I do, I just finished recording another video. I did not restart my computer. This happens to support the HA. Okay. All right. So, or we can say we reject the null hypothesis, the HO, and there's significant evidence to support the alternative hypothesis, the HA. Now, be careful with the wordings because sometimes the professor wants it different ways. Or maybe if you do one of those multiple choices, they would like, for example, instead of using rejection, they might flip these words around. I mean, I have seen so many different ways that they word it. Sometimes they even word it just using the story. Okay, they might say, for example, the suggestions that the actual percentage of the type A donations are not different, not difference, are not supportive to be different. So just watch your wording, okay, guys? Now, if you're wondering what if, and what if it was the other way around, and instead of less than, it'll be greater than p-value and the alpha greater than, then the conclusion will be in wording backwards, as so. we will say, sorry about that. We'll say we failed to reject the HO. We failed to reject the HO. And there is or we must say we do not reject the HO. So it failed to reject the HO and or we do not reject the HO. And then about the HA, we will say there is no significant evidence to support the HA. Okay, I apologize for my handwriting. For some reason, my computer and my tablet is not working out with me, and I just noticed that I'm in a really bad position. That's a really unprofessional of me. This is like first thing before you do these videos, make yourself comfortable. Anyway, so that's pretty much it for this problem. Let me zoom in. Oops, too much. Yep. So a random sample of 150, and then 82 were type A. Okay. Notice that my population is considered to be my mean. And when so this 40% was the study done this in the past, and they found out that the population has a 40%, and then they decided to do a sample of 150 or study and came up with 82. So yes. Okay. All right, guys. Again, don't forget to like the video, comment below, and share it, and subscribe. And feel free to come, give me suggestions about future videos, okay, and also future problems. This textbook is pretty good. It has many problems, and I just pick one of the, whichever I think is good. And if you guys want me to do it using Excel, I can do that too. Or using the table. All right. All right, guys. Have a good day. Bye.